In this lesson, lesson 1.3, we are going to learn about properties of parallelograms. So as you already know, parallelograms are four-sided figures, so quadrilaterals. And so let's first talk about some things that we know about quadrilaterals. So quadrilaterals have four sides, and it doesn't matter what a quadrilateral is. It could be as special as a square, or it could be just a random four-sided figure. So it doesn't have to be any particular type. But another thing about quadrilaterals is if you were to draw a diagonal, it forms two triangles, and so one triangle sum is 180, the other triangle sum is 180. And so we find out that the sum of the angles in a quadrilateral is 360. And so those are two things about every single quadrilateral that's true, no matter if it's special like a parallelogram or a square or a rectangle or a trapezoid, or if it's just a random quadrilateral with four sides. So before we get into the notes, let me take you to a picture. Here's a parallelogram. And the reason that I know it's a parallelogram is because of these symbols right here. And so if you remember, we've learned before that those symbols on lines mean that the lines are parallel. And so if you notice, these two that I have circled, they're matching arrows, and so that means that BC is parallel to AD, and that's what that picture tells me. And then because of these symbols right there, that tells me that AB is parallel to CD. So that is the definition of a parallelogram. A parallelogram is a quadrilateral where opposite sides are parallel. And that's it. That's all that the definition says. So there's nothing else that's part of the definition of a parallelogram. So what I have written up here in purple is a parallelogram definition. And so reading that together, it's a quadrilateral where both pair of opposite sides are parallel. Okay, so that's the definition. Now don't forget what we just talked about, that in a quadrilateral the sum of the angles is 360 degrees. Now there are some theorems that follow from the definition, and that just means that we can prove them. And so as far as proving them, we're going to have the opportunity to prove these, but we're also going to use them to find missing parts and pieces of parallelograms. So what I want you to do is I want you to find your vocabulary sheet, and let's go through these ideas and these theorems and definitions and things like that. So the first one is that in a parallelogram, opposite angles, and so when I talk about opposite angles, I'm talking about angles like A and C. Those are opposite angles. I'm talking about angles B and D. Those are opposite angles. So when I say opposite angles, that's what I'm saying. And so in a parallelogram, opposite angles are congruent. Now, like I said, we can prove that, and we will. But that's a theorem that is true for all parallelograms. Okay, now the next one is talking about consecutive angles. And so for consecutive angles, consecutive means one right after another. And so that means like B and A are consecutive angles. B and C are consecutive angles. C and D are consecutive angles. D and A are consecutive angles. And so there are two angles that are next to each other. Okay, so when we're talking about a parallelogram, what about the consecutive angles? And so one thing that we know, remembering back to parallel lines, and then if we say this is our transversal, what do you know about these two angles? So think back to what you know about them. And that's where this is going to come in. Consecutive angles are supplementary. And we can prove that. And the way we would prove that is just by, showing this with parallel lines. And so that's actually not a very hard proof. Okay, the next one, opposite sides. Opposite sides, we're talking here with opposite sides, I'm talking about BC and AD. Those are opposite sides. So this side and this side, those are opposite sides. AB and CD, those are opposite sides. Now I already know by definition that they're parallel. But what else I can prove is that opposite sides are congruent. And you might think that that's an obvious thing, but it's actually not part of the definition, and so it's something that follows from the properties that we have. Now the last thing, this one's a little bit harder to wrap your head around, but it's about the diagonals. Okay, so the diagonals are where it's joining one vertex to the opposite vertex like that. That's a diagonal. And then we have another diagonal like this. Now, if you look at those two diagonals, the first thing that people want to say is, oh, they're the same. Look at them. Do they look the same? Do they look like they would measure the same amount of inches or centimeters? Hopefully you're saying no to that one. Diagonals in a parallelogram are not congruent. Okay, just for a general. Now we're going to find some special cases. And we talked a little bit about this last year, but in a rectangle, which is a special parallelogram, and it's special because of the 90-degree angles, in a rectangle, guess what? The diagonals are congruent. And in a square, they're congruent. But in a rhombus, they're not congruent. Okay? So part of a parallelogram is not that the diagonals are congruent, but what do they do? And so one thing we find is that the diagonal AC, it cuts BD into two equal pieces. And likewise, BD cuts AC into two equal pieces. Now the green pieces are not equal to the red pieces, okay, but the diagonals bisect each other, okay? So we're going to say that they bisect each other. Okay, so these four things, 1, 2, 3, and 4, these are four things that we know about parallelograms along with the definition. So this could actually be number 1, but I'll say 5 because I already started number 1 somewhere else. But with the definition, we've got these other four things that always happen in parallelograms. So using that knowledge, we're going to go to the notes and we're just going to do some practice. And I'm not going to do all of these problems on the video, but they will all be in the notes that you can find online. So I'll skip some of them, but I'll do some of them with you. Okay, so on numbers 1 and 2, they're both the same idea because they're using consecutive angles. And so number 1, it says find the measure of the numbered angles. So find angles 1, 2, and 3. So if I know this one is 112, I know that one's 112. Why? Because they're opposite angles. So how would I find 1 and 3? Well, if you find one of them, then you found the other one. So what do I know about, let's just say 112 and angle 3? What do I know about them? I know that they're supplementary. So 180 minus 112, and that will give you the measure of angle 3 and the measure of angle 1. So I'll just let you go ahead and come up with that. Now number 2, what value of t makes UVWX a parallelogram? So if this is going to be a parallelogram, if you notice we don't have these lines telling me that it's a parallelogram, but it's saying if t had a certain value, then this would have to be a parallelogram. What would that value be? So in order for this to be a parallelogram, what has to happen with those two angles? So think about what we just talked about. What do those two angles have to be or do? So hopefully you remembered that they have to be supplementary. So I'm just going to set up an equation and I'm going to solve that equation. So I'm going to have 11t plus 15 equals 180. And so 11t, remember about showing your work. And so t is equal to 11 goes into 16 one time with 1 left over. So then, with 5 left over. So then 11 goes into 55 5 times. So t is equal to 15. If t was equal to 15, then that would be a parallelogram. Now it's not t degrees because t is just the value. We've already got the degree symbol right there, so you don't put the degree symbol on your answer. Okay, for number 3, you're going to do the same thing where you're going to set up some equations to figure out what you know about this. Now notice that these two angles have b's in the variables and these have a's. So what you want to do is you don't want to set up something about these two angles because then you have two variables. So you want to do something where you only are dealing with one variable. So think about which of the properties that we talked about, which of the theorems would help you do that. And so you can go ahead and look on the notes online if you aren't sure how to figure that out. Okay, number 4, what value of y makes PSR in a parallelogram? So if you look, I know that this is parallel, so it has to be a parallelogram. But in that case, what would y have to be? So what do you know about the sides in a parallelogram? Well, the opposite sides are equal, so you just have to set up an equation. Turns out you don't really need that one for anything. There's nothing that helps with, okay, so you don't have to worry about that one. But solve that equation and you'll get y is equal to 6. And so if that was the case, then this one would also be 20. Number 5, notice that it's showing the diagonals in a parallelogram, so I know it's a parallelogram, but the picture is showing the diagonals. And so this is equal to this one right there. And then this one is equal to this one. So since I don't have anything right here, that's not helpful to me. But I do know that these other ones, the green ones, are split, and so they're equal to each other. And so this is the equation that I would have to solve. So solve it for A. Okay? And so you just have to show your work. So not a lot of work to show there, but the part of what you're showing me is that you can set up an equation and that you can solve your equation. Okay, now what we're going to do is we're going to go into some proofs, and we're going to be using these theorems that we learned last year. Some are postulates, some are theorems. So let's just review those really quickly. And so I'm going to pull out another piece of paper here. So I've got congruence theorems. So in order to prove that two triangles are congruent, we have got some ways that we can do that. So side, 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 angle, side, angle, side, angle, 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 side. And those are the 4 tests. Now there's also hypotenuse leg if we have a right triangle, and we talked a little bit about that in the last lesson. This is only for a right triangle, and so it's useful sometimes, but generally speaking, we're not going to be pulling that out a lot. So the other ones are really where we're going to be using those a lot. So side, 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 remember that is if all 3 sides of one triangle are congruent to all 3 sides of the other triangle, then the triangles are congruent. Side, angle, side, the angle has to be included. So if you've got 2 sides and an angle that's included, then that's where you're going to get side, angle, side. The angle, side, angle, the side has to be included. So you're going to have an angle and a side and an angle. And so then that's where you're going to get that. The angle, angle, side is going to be your 2 angles followed by your side. Okay. Remember that if it spells a bad word, forwards or backwards, then that is not a congruent statement. Now, after, and this is super important that you remember this, but after you've proven congruent triangles, then you can use CP-CTC. And so if you remember what that stands for, it stands for corresponding, I'll write it down, corresponding parts of congruent triangles are congruent. Okay, so what that means is it means that you're showing that the corresponding parts of triangles that are already congruent are congruent. So if I know that this triangle is congruent to this triangle, then I know that all their pieces match that correspond with each other. Okay, so that's what I know from that. So going back to the lesson then, okay, we're going to do some proofs with that. So number 6, it says, given that ABCD is a parallelogram. Now, even if it didn't say that, if you look at the picture, I can tell that from the picture. So I would write one way or the other that ABCD is a parallelogram. So I'm going to start my proof with that. I don't even know what I have to prove yet, but I know that I'm going to start with that. And the abbreviation for parallelogram, you're going to love this, is a parallelogram shape. So you can just write that. And the reason number 1 is given. Okay. All right. Now we notice that in our picture, we've got angles 1, 2, 3, and 4. Okay. So we're going to have to do something with those angles. Let's look at what we're supposed to prove. We're supposed to prove that triangle ABD, so that's ABD, is congruent to triangle CDB. Now that means that we have to show that C and A correspond to each other, B and D correspond to each other, and D and B correspond to each other in one triangle or another. So B doesn't always go with B. So if I'm going to prove that these 2 triangles are congruent, I need to look to see which of these could I use for that. Okay, so which one of those would help me? Now, since I know it's a parallelogram, we have some options here, and I'm going to just throw out a couple of options that we could use, and you can use any of them. Okay, so one thing that we are going to want to use probably is that DB is congruent to itself. So I could write, and you may want to wait and see all of your options before you decide which way you'd want to go on this, but I'm just going to write a few of them down. So DB is congruent to DB, and what would the reason on that be? Remember that that's the reflexive property. Okay, now some other things that you could say is you could say angle 2 is congruent to angle 3. Why? Okay, this one's a little bit harder. Why would those 2 be congruent? Look at what we've got. We've got a side and another side that are parallel, and if this is my transversal, what is angle 2 and angle 3? So I could say angle 2 is congruent to angle 3, and the reason is because they're alternate interior angles. And alternate interior angles are congruent. Whoops, let me Erase that so I have room. Alternate interior angles are congruent. Okay, now I'm going to erase the markings I've got here so I can mark what I know. So far I know that this angle is congruent to this angle. I know that this is congruent to itself. So I could say, well, what about angle 1 and angle 4? I could say, well, since these two lines are parallel and there's my transversal, 1 and 4 are alternate interior angles. So I could do that too. So one option I have on my proof is I could throw in angle 1 is congruent to angle 4 right there, and it falls under number 3 because it's the same reason. And so with that, which triangle theorem could I use now? So I could say that triangle ABD is congruent to triangle CDB. Why? Because of angle side angle. Okay, now that, like I said, that's one option. Another option you could say, for step number 2, you could say, how about this? AB is congruent to DC. Why? Because they're opposite sides of a triangle, or parallelogram, and opposite sides are congruent. So number 3, opposite sides of a parallelogram are congruent. Now for the same reason, we could say that AD is congruent to BC. So I can just put that in the same reason. And then since I already know that DB is congruent to itself, then I can say triangle ABD is congruent to triangle CDB. And why would that be on that one? It would be because of side, side, side. So that's another option that I have. Okay? Now, some other things that you could use. You could say this angle is congruent to this angle because they're opposite angles. Angle 2 is congruent to angle 3 because they're alternate interior angles. And then DB is congruent to itself, so then that would give you angle, angle, side. So you see, you have a lot of options, and that's not even all. I mean, you could do other things as well, some different combination to get one of those congruence tests. But there's other ways that you can do that, depending on which test you choose to use. So on a proof like that, you just make sure it works. You just make sure that you're proving all of the things that you need to prove. Okay, number 7, given the ABCD as a parallelogram, prove that AB is congruent to DC and AD is congruent to BC. So we're going to prove that theorem that says that the opposite sides are congruent. So right here, we're going to prove this right now. Okay, so we're going to prove it. And so we can't use that to prove it. It's like, prove that, you have an A. Well, I have an A. That's not proving it. So that's probably a dumb example, but you can't use what you're trying to prove in order to prove it. And so one thing we have to steer clear of is we cannot say anything about AB being congruent to DC or DA being congruent to BC. Those are off the table. So instead what I'm going to have to do is I'm going to have to figure out some way to show that they're congruent. And if I look at what I just did in the previous problem, look at what we just did. We proved that these two triangles were congruent. If two triangles are proven congruent, what am I able to say about their parts? I'm able to say that their corresponding parts are congruent. So if you look at this, I'm going to start with the same given. Okay, I'm going to do dot, 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 and I want you to come up with triangle ABD is congruent to triangle CDB. And your reason might be different than somebody else's. It's going to depend on what you have in the middle right there. So I gave you a couple of different ways that you could prove that those two triangles are congruent in the last problem. So I want you to do it, but do something different than what you have written down right there. So go about it a different way and prove that they're congruent. Now that's not all. Okay, now make sure you have a reason there, like side angle side, 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 something like that. But once the triangles are congruent, then you can say that AB is congruent to DC and AD is congruent to BC because of CPCTC. Remember that when you prove something, what you're being told to prove is the final step. Okay, that after that, nothing else comes. Okay, there's nothing else that is important. So you have to work your way logically to that step. Okay, for the last problem, number 8, we're given the same information that we have a parallelogram. We have to prove that angle DAB is congruent to BCD, and we have to prove that angle ABC, so 2 plus 4, is congruent to CDA. So what we're proving now is we're proving that theorem, that opposite angles are congruent. So I'm going to leave this for you, and I want you to stop the video, and I want you to go through and prove this. Okay, so very similar to the other proofs that we've done, how are you going to prove that those angles are congruent? So think about what we did in the previous problems. Start off with, how are you going to prove that this angle is congruent to this angle? You cannot say that they're congruent because opposite angles are congruent, because that's what we're trying to prove. So you can't use that in your proof. How would you do that? And then you need to think about how would you do 2 and 4? Okay, that's going to be different. That's going to be a little bit harder, because what you're going to have to do is you might need to think about doing a different line. So maybe you want to think about drawing a line AC so that you can have this whole angle and that whole angle. Okay, because you're going to have some different triangles. You're going to have to prove this triangle and that triangle. So this proof is going to be a little bit longer, but you need to make sure that you understand that angle 2 is part of a different triangle than angle 4 is. So if you prove that these two triangles that we have here are congruent, you can't say that so angle B is congruent to angle D, because it's two parts of two different triangles. So you would have to then do it again, except for using a different diagonal. When you're done with that, I want you to check the notes online, and I want you to make sure that your proof has the steps that are in that proof there. And it may not be in all the same order, and it may not be precisely exactly what we have, but you need to prove all of the things that are proven there. Okay, so do the best you can with that, and then go study the notes on it, and hopefully you can see the logic that's going to follow, and then in your homework you'll have the opportunity to do some others. Make sure you have all of these things written down on your vocabulary page, and then see me if you have any questions.